Hello, I hope you can hear me. So this was your question that we have to design class D chopper in the MATLAB, in which we have two diodes, two MOSFET, and load is RL, and there is a back EMF which is E voltage, which is opposite to the input voltage. Okay, and the one more thing is that let's say if we make it this close and make this close, so what will happen across the voltage source? So there will be voltage source will be flowing from here, and then there is also a short circuit or a closed circuit, so this will also flow here. So there is a short circuit across the source which we don't want. So this is the logic, this is the main thing behind the what we can say this simulation that we need to be keep in mind while simulating the things. Okay, so don't make these mistakes while thing. So this is the simulation model that we have developed. How we have developed, let me just open two screens simultaneously so that you can have the idea better. So this was your question. You have a 6 volt DC source, so you can click by DC source by like this and click on, look, this is 600-volt DC. Okay, now you have RL load, supplies a RL load. This is RL load. How we have chosen, you can see RL, RLC, RLC. So you can, oh sorry, not this one, RLC. This is series RLC. And you click, this will open. Okay, now the resistance value is given is 1.5 ohm and the inductance is given 4 millihenry, which we have read. And is with a back EMF of class D chopper as shown in figure 3. The road parameter, the E voltage is another source which is opposite, it is 200 volt. Now they say if is the chopper operating frequency 250 hertz. Okay, we will see how to end the T on time is 2.5 seconds. So what is 250 hertz? 250 hertz is 4 millisecond frequency. Let's say calculator to 1 hour 250, which is time period which is 0.004, which is 4 milliseconds. So total time period is 4 millisecond and T on time is 2.5 millisecond. So what will be duty ratio? Duty ratio is 62.5. This is the most important thing in the this simulation. Okay, so you have to remember this in your mind. Now the other thing is, I have explained you how to calculate duty ratio. So you have chosen these are these things. Now let's draw the circuit. This is MOSFET, this is MOSFET. So you can just write MOSFET and this will open. This will open. Okay. So similarly you have diodes. You can write diodes, diode. Then this will open. These two things. These are the voltage measurement. You can open by using voltage measurement. Similarly, you can open the current measurement as well. So these are the, and this is scope which you can open by different means. Okay. So just give me a minute. Now you have understand how to open or how to choose all these components that have. This is power GUI which is necessary for simulating these circuits. You have to choose bus from the circuit. Power GUI. Okay, that's all. Now this was the main thing. Now these are the control diodes which or MOSFETs which need to be switched off at different time period, which is duty ratio is 2.5 seconds. And I have told you that we cannot simultaneously on these two MOSFETs at a time. We have to avoid that these boards should not be on at a specific same time. So for that we have device logic here, which is very much necessary. So all this rest is making the circuit joining the things. Now he is asking you to sketch the waveform of VOIO. So how we have, this is the voltage measurement used across this load and we have given to this scope. Similarly, we have installed a emitter in series and given this. Similarly, ISH1 here current meter, and this is given to this code. Similarly, ID1 and I2. This is ID1 for my main ID1. This is for ID2, and this has been displayed here. Similarly, I have displays IS and VS, which is also being asked here. So we have how this is how we have scope everything. Okay. Now the main important thing which is here, that I have told you that these two MOSFET should not be on at a specific time. So we have used a pulse generator which will be used for the switching on these MOSFETs at different times. So amplitude, this is the maximum output of this pulse generator which is given to these MOSFETs. Okay, and this is the time period which is 250 hertz is frequency, so 1 hour frequency is time period, and we have calculated total duty ratio is 2.5 millisecond. So at the end we got duty ratio of 62.5, so we have given this. So these are the things. Now you have seen I am giving this pulse generator output to A, but I am using a NOT gate. NOT mean opposite. Whatever the output at A, the this will be inverted by this NOT gate, because we don't want to switch on this as well as this at a specific same time. So that's why we have inverted and then again multiply with 10, because here the amplitude is 10. So this will give output of 1 or 0, and multiplying with 1 or 10 it will give output. So this B is given here and A is given here. Now see the waveform first. Look, this is the switching A and this is B. You can see when the switch A is on, B is off. When B is off, on, A is off. This is the 62%, and this is rest of the percent, because you know this is 4 milliampere total time period, and from that this is 50%, and 50 of half is almost 62. So you can see 62% MOSFET A is on and rest is MOSFET B is on. So that is the main thing that you need to do. Now we have, let's simulate it and validate the result that we have to got. For validating the result, you can see this is the output voltage which is 600 volt. This is output current which is increasing. Similarly, this is the switching across the what we can say MOSFET number 1 and MOSFET number 2. You can see the MOSFET 1 is conducting in this region, you know, because at that time MOSFET 1 is on. On the other hand, MOSFET 2 is in off condition, and similarly MOSFET 2 is on in negative direction, right? But MOSFET 1 is off in this region. Similarly, the again, why this has been here there, because of the back EMF, and why, and back EMF an inductive effect, because you know there is an inductor and the voltage source as well. So I hope you have understand these things, and let me see how much time I 2 minutes I have to. Now you have seen all the things. Let's see these things there. These are exactly same as your problem as well. You can see these are the calculation which you can use by yourself for various purpose. Now this is ISH1. Let's see ISH1 here. You can see there is a bit difference, because these are the ideal conditions and these are the real simulated condition. In real time, it cannot go at once to its maximum value. It will take some time to reach its value, because there is an inductor as well. So that's why you can, but still you can see that it is on at 2.5, from 0 to 2.5 millisecond, and off from 2.5 to 4 millisecond, off from 2.5 to more 4 millisecond. On the other hand, ISH2 is on from 2.4 millisecond and till 4 millisecond. You got these two. Now let's see V out. This is V out, right? You can see, where is the diagram? V out is maximum 600 volt, and this and at From 2.